quite successful. And so we have mocked up and we have figured out that this is what our music management application. We want to track people's tracks, know something about what artists and albums and genre they are, and we want to have ratings and how many times we played them and how long they are. Well, that's the data that our application needs to represent. And we've done testing on this and wireframes, and everyone loves this. A great user interface. And so this is how it's got to look. But we're going to have billions and billions of tracks in these things, and so we want to come up with an efficient database to handle this. And so we're going to take a look at this and look at each of the columns, and we're going to ask ourselves, is this column part of one of our existing objects, our existing tables, or is this object have to create a new table? And then once we've defined those different objects, we connect the tables together and model the connections. Now, a little trick to kind of make it a little easier on ourselves is we can look in these columns and look in the columns that have duplicate information vertically that's string information. So a rating is just a number like 0 through 5. So we don't worry too much about integers and numbers and that kind of stuff or whatever, but we do look for strings. And the problem here is we got like these strings occur many times. And so these are the problems. And so we have to put these things where there is replication of string data kind of in the vertical dimension. We have to put those in different tables. And so we'll start out. Now the first question that you have to ask yourself when you're going to draw this picture of how this data is in multiple tables and connected together is, what is the first one that you're going to write down? And this is an interesting debate, and often people are sitting in a conference room, and people who have experience kind of know what to do. Usually if it's a multi-user system, like a learning management system, the users might be the central concept. Perhaps the courses might be the central concept. This is a single user system, and so you can think, well, what is really this application about? It's not about people, it's one person, but it is about tracks. And so we can say, okay, here we'll take the track is probably the sort of most foundational notion of this application. And then we can take and say, okay, now that we've decided that tracks are the foundational notion, which of these columns are simply an attribute of the track? Not really, and the cheating way and the easy way in this particular one is like these numbers, all these numbers, like this number and these numbers, not that one. They just go along with track. And so we'll put that in. We got the track title, rating, length, and count, and we put that in. And then the question is, we've got the remaining things are, we've got the artist, we've got the album, and we've got the genre. And so we can say, okay, well, we've got some vertical duplication, so we're going to say, okay, this track probably belongs to an album. So let's pull out the album into its own table. Oops. Pull the album out into its own table. And so pull the album out into its own table. And so that pulls that out, and then you say, okay, what would be the next thing that we're going to pull out? So we pulled out the track, we've got this taken care of, this taken care of, that taken, now we've got the album. Well, albums belong to artists, so let's take out the artist. And then we'll pick where the genre belongs, and we'll just say that the genre belongs to the track. And so, because there might be albums with more than one different genre. So each album is not necessarily a rock album, it could have a rock track and a country track, etc., etc., etc. And so now what we've got is we've got 4 tables, right? We've got a track table, we've got an album table, an artist table, and a genre table. And if we sort of double check, all of the columns that had vertical duplication in them now have their own little table. So we can eliminate, the next thing we'll do is to show how we're going to eliminate this vertical data replication by showing how you represent these relationships that we just created inside of the database. Now we're going to represent these relationships in the database. And again, what we're trying to solve here is this notion of database normalization, third normal form. There is so much theory, right? But in this lecture, I'm just going to condense this down to don't replicate string data and use what are called keys. Use integer keys to point at those things. And we're going to use these integers then to point. So we'll assign each row an integer, and then we're going to point from one row to another using those integers. And so we're going to add these special key columns to each of the tables, and help in the database will even give us help managing those. Now, and so we still need to keep track of, who is the creator of the album, which album a track belongs to. We've got to create these relationships, and we have to come up with ways to store those relationships. And so the idea is we're going to have a column in a table, which is the key column, and we're going to call this the ID column. And so this is a row. It might have many bits of data here, but in this case it's just the name of an artist. So this album is going to belong to an artist. And we're going to assign a number inside the database, and so that Led Zeppelin is 1 and AC/DC is 2. And so we have this key. This is called a primary key. And then later, when we want to say that the Who Made Who album really was done by AC/DC, we put the number 2 in. And so the difference here is, instead of saying AC/DC in this record, we just put the number 2 once we've established this number. So we assign keys, and then we have these pointers that point back. And so that's how we model a relationship with these small integer numbers. And so there are 3 basic kind of keys that we use. One is the primary key, and that is that little ID column that is just a number. But once we give Led Zeppelin the number 1, Led Zeppelin is has got the key 1 for the rest of that database. The logical key is the text area that we use that you might look up. So the title of the band or the title of the album, that's the logical key. And then the foreign key is one of these keys that is really pointing to the primary key of another row. So that's called a foreign key. And you might think that you want to use something like an email address as the primary key for a user table or something like that. The logical key should always be separate, and there should always be a primary key, that integer number. Because things like logical keys do change. People do get new email addresses, and if you've got that email address as a foreign key pointing all over the place, it doesn't work out so well. And so that's why you use these small integer numbers that have no meaning outside. So sometimes if you're on a system and you see a URL and you see some number like 422,016, you're like, oh, that turns out to probably be my primary key in their database. So sometimes you can look in a URL and you can see these primary keys in the URL, but they don't mean anything outside of that particular system. So like I said, a foreign key is a key that is really pointing at a row in a different table. And so we have the album has a primary key for it, but the artist underscore ID points to a row in the artist table, as we will soon see. I have a naming convention, and in my naming convention on this lecture I use ID for the primary key, and then artist underscore ID I use uppercase for the table names, and then artist underscore ID says this is a key, this is just a key that points to the ID key of the artist table. And so that's what I do. So you'll see in all my stuff I'll use that. It's a convention. It's not something SQL forces you to do, but you will find when you go to organizations and work on their databases, these conventions are very important, so I can do something and you can understand the rules in which I created it. Some of these, you'll find this used by some people, you'll find completely different conventions, and that'll be okay. Whatever convention your organization uses, learn that convention. So now we're going to talk about how we put these keys in, and then how we actually make the connections from one row to another row. So now that we know what a primary key, logical key, and foreign key are, we're going to actually start putting these together and creating tables that have these kind of values in them. So when we were done, we drew this picture that was sort of a logical model of how our data would be spread across 4 tables and how those tables are connected. Now we have to take this and we have to map it in a way that leads to the columns and the needed columns in each of our database tables. And so here's what we do. We basically have to take, and for each of these, when we're going to build a track table, we add a primary key. So we just added an ID field to every one of these things, and that's so we have a place to store the sequence number of this particular row. We have logical keys, we've just marked those are strings, and then we things like, rating, length, and count, they just kind of go in here. And now we have to model a relationship. So what we do is in the table that the relationship starts from, we put one more column in, and this is the one I will name album ID, and that just is an integer column that's going to record the album ID. So this might be 16, and then 16 goes in here. So there's one of these columns that's a foreign key that points to this, and that's why it's foreign. this is a key that's not in the track table. This is a key in the album table that we're pointing to. And so there's a foreign key. And that's what we have to do. And we just